8.4, we're going to learn how to factor, and the first thing we're going to look at is a GCF, or greatest common factor. Now, factoring is like the opposite of distributing. So if I have something like, we've done like this, like x plus 3, all right, and I would distribute, and that would be equal to 2x plus 6. For factoring, they're going to give me the 2x plus 6 originally, and they want me to make it look like that. Okay, so it's like the opposite of what we have been doing. Okay, so GCF is the largest number that can be divided evenly into every coefficient or constant. So every number, I want to be able to divide it evenly. Okay. Oops. All right, so here my coefficients are 18, negative 15, 3, and negative 6. Okay, so what number can I divide all of those by? The answer is 3. So what I'm going to do is I'm going to divide every term by 3. And when I do that, 3 is my greatest common factor. That goes outside. And then what's the answers after I divide each of these are going to go inside the parentheses. So 18 divided by 3 is 6y squared. Negative 15 divided by 3 is negative 5y cubed. 3 divided by 3 is 1, so this is just 1y. And then negative 6 divided by 3 is negative 2. So this would be my factored answer. All right. Now we can do the same thing with both numbers and variables. So here I have 32, negative 8, and 16. All right, what's something I can divide all those by? Well, I can do 4. All right, so let's do 4. And then they all each have an x. So included in my GCF is also going to be an x. And I can use whatever the smallest exponent is. So the smallest exponent here is 2, because we don't want any negative exponents on our answer. So we can always divide out the smallest exponent. So 4x squared is my GCF. All right, 32 divided by 4 is going to be 8, and then x to the 4th divided by x squared, I subtract those exponents, and I'm left with x squared. Here, I would have negative 2x, and then 16 divided by 4 would give me 4, and my x squareds would cancel each other out. Now, here's where we have to double check. Some of you, I did this on purpose, by the way, but some of you may have been yelling at the screen, 4 is not the greatest number. 4 is not the greatest number. Okay, so after you divide something out, make sure you double check. 8, 2, and 4 can still all be divided by 2. So that means I didn't get the greatest common factor at the beginning. But it's okay. We can just divide again. So now I have 4x squared, and I'm also going to have a 2 outside. All right, so now let's divide again. 8 divided by 2 would give me 4x squared. Negative 2 divided by 2 would give me negative x, and then that would be 2. And then on my outside, 4x squared times 2 is 8x squared. So that means my original GCF should have been 8, and I just picked the wrong number, but it's okay because we got there. All right. Now, the last example that I'm going to do with you guys, we have multiple variables. Okay, so what are my coefficients? Let's always start there. 45, negative 1, 15, and negative 5. There's nothing I can divide all of those by because negative 1 is already as simplified as it goes. Okay, so now let's look at our variables. Okay, we have x, y, and z. Does every term have an x? The answer is yes. What's the smallest exponent? Well, this one has a 1. All right, so that means I can divide an x out of every term. Okay, does every term have a y? The answer is yes. What's the smallest y exponent? I've got 2, 2, 4, and 1. So I'm going to take a y out of every term. And then does every term have a z? This one does, this one does, this one does not. So because it's not in every term, z is not part of my GCF. Okay, so my GCF is just x, y. And then I'm going to go through and do my division. My coefficients aren't going to change because I'm just dividing by x, y. So x cubed divided by x is x squared. Y squared divided by y is y, and then I just keep that z to the 3rd. It just stays there. Okay, here my x's would cancel out, so I would be left with y, z. All right, on this one, I would have 15. X squared over x would give me x. Y to the fourth over y would give me y to the third. And then here I have negative 5. My x's would cancel out. My y's would cancel out. And I would just be left with z squared. And that would be my answer. Okay, so I want you to pause here and try this number, or this example. So you should have found that your GCF was 2, and then x squared, y squared, z squared, because that's the lowest exponent for each variable, and then divide that out. So if you did not get the same answer that I did, I want you to put a star by this one so you can ask about it in class. All right, next thing that we're going to learn how to factor is what's called a difference of squares. So that happens when we have two terms. And what we're checking is, are both of our terms perfect squares and are they being subtracted? That's the only time this works. All right, so if I look at this example, x squared is a perfect square and 16 is a perfect square. So to factor this, what I'm going to do, because there is no GCF, I'm going to take the square root of each term. So the square root of x squared is x. The square root of 16 is 4. Okay, and what I'm going to do is, in one set of parentheses, I'm going to add those two things. And then in the other set of parentheses, I'm going to put the same numbers and I'm going to subtract them. And then that is fully factored. And the way that we know it's fully factored is if I were to go backwards and distribute this out, I should end up with my original problem. So x times x is x squared. X times negative 4 is negative 4x. 4 times x is positive 4x, and 4 times 4 is negative 16. Then when I combine my like terms, negative 4 plus 4 is 0, so I'm left with x squared minus 16. And that's how you know you have factored correctly. If you multiply them back out, you should get the original problem as the answer. Okay, this one, y to the fourth, anything with an even number is a perfect square. So z squared is as well, so that means we can do our difference of squares. The square root of y to the fourth is y squared. The square root of z squared is z. I'm going to do one of them plus, and then I'm going to do those same two terms, and the other ones are going to be minus. Okay, now sometimes we have to put these two methods together. So 3m squared is not a perfect square because 3 is not a perfect square, and 27 is not a perfect square. But these two do have a GCF. I can divide both of these terms by 3. So when I do that, now I have 3 and I have m squared minus 9. Okay, m squared is a perfect square. 9 is a perfect square. So this now I can do my difference of squares. And I'm just going to leave this 3 hanging out outside the whole time. Okay, the square root of m squared is m. The square root of 9 is 3. One set is plus. The other set is minus. And that would be fully factored.